surface area of prisms and cylinders. Lesson 12.2, and like I tell you, just about every day I would always include today's date in your notes. I think that helps your notes be organized, and it's just a good way to take notes. So, surface area of prisms and cylinders, lesson 12.2, and be sure to include today's date. Now, let's first start with a definition. Should be an I right there. Definition of a prism. If we are going to learn how to find the surface area of a prism, then we need to make sure everyone knows what a prism is. Thus, once you know what a prism is, you will know to use the correct formula that goes with finding the surface area of a prism. Do you see what I'm saying? It's important you recognize a prism so you will know what formula to use. Here's the definition. A prism is a polyhedron that has two parallel congruent faces called bases. You are not responsible for this on a test or a quiz, but I still would like you to write it down. So take a second and please copy this down. A polyhedron has I'm sorry guys, a prism is a polyhedron that has two parallel congruent faces called bases, okay? And I will give you a picture of this here in a couple seconds so you'll understand better what I'm saying, okay? And by the way, the other faces are called lateral faces. I would make note of that in your notes, okay? The other faces are called lateral faces, and I'll be talking about that here in just a second, alright? I'll wait just a second while you copy these two notes down. A prism is a polyhedron that has two parallel congruent faces. They're called bases, and the other faces, by the way, are called lateral faces. Now, so that you don't have to try to draw these pictures in your notes, you just might want to make a note in your notes that says page 593, okay? And then make sure you study page 593, okay? If you'll look at the screen here, or you can turn in your books to page 593 if you want to. That's totally up to you. But either way, either look in your book or look here at the screen. You're going to see two examples of prisms. Now here's what they're talking about. Do you see how this top face here, I just tried to highlight it for you. Let me use a different color. It shows up a little better. Do you see this top face here? Is congruent to this bottom face here, and they're also parallel. They are exactly parallel. They are two planes that are parallel. Well, anytime you have a polyhedron that has a set of congruent parallel bases, then you have a what? Period. You have a prism. Period. Okay? So if your polyhedron has two bases that are, or two faces that are congruent and parallel, then you have a prism, and those two faces are called your bases, okay? Your bottom base and your top base. So over here, look, do you notice how this face here is a triangle? And it's congruent to this face here, and it's also parallel, okay? Now, I know it's slanted, but that does not matter. You have a prism. If you'll listen to me, students, please. You have a prism if you have three things. You have a prism if you have a polyhedron, and if you have two faces that are congruent, and those same two faces are parallel. If you have those three things, then you have a prism. It has to be a polyhedron, and both of these are polyhedrons. Remember, a polyhedron is a solid in which all of the faces are polygons, okay? So, you have to have a polyhedron, and you have to have two faces that are both congruent and parallel. You have that, and you have a prism. Now, look at some other names that you need to be familiar with, okay? I'm not too worried about lateral edges. That's not a huge deal. This is huge. You need to understand the difference between height and slant height. Do you see that? The height of a prism prism is the vertical or the perpendicular height that runs from one base to the other base. That is the height that we're talking about when we say height. Slant height is if you have one of the oblique prisms. It might not be triangular, but an oblique prism. So it's slanted. That's the height that runs from here down to here. In other words, here's how I've taught it in the past. If you had a friend and you wanted to throw a rope to him and have him climb up the side of the prism here, and you were standing up here, now here, just wait for it, okay? This is my great drawing skills that I have. And you throw a rope down to your friend down here, and they're going to climb up the side of it. That's the slant height. Got it? However, if you were to drill a hole into the top of the prism and drop a rope down inside like this, a rope that dangled straight down to the bottom like that, was perpendicular, and then you slid down that rope, that would be the height of the prism, okay? So one is vertical, or you can say it's perpendicular to the bottom base. That's the height. The other is a slant height, okay? Something else you need to be familiar with is the lateral faces. And I mentioned that to you right back here. I said the other faces that are not the what? The bases. The other faces, not called the bases, are going to be lateral faces, okay? And those lateral faces, by the way, will always be parallelograms. Do you want to make note of that? Might be a good thing to make note of. The lateral faces in a prism will always be parallelograms. I would make note of that. The lateral faces in a prism will always be parallelograms. Alright, so take good notes on this. Pause the video if you need to. Let's continue on, okay? But you need to know what bases are, what the height is, what the slant height is, what lateral surface faces are, and most importantly, what a prism is in general, so you can recognize it, okay? It's a polyhedron that has two faces that are both congruent and parallel. You have that, and you have a prism. Now I want to show you how to find the surface area of a prism. I would like to ask you to not take notes, but just listen, okay? So I know that kind of shocks you. There's not many times that Mr. Error is going to say that, but I'm asking you, it's kind of funny, I'm asking you to not take notes, but to just listen, okay? Now if you want to take notes, that's fine, but I'm not going to wait for you, okay? Now, here's a prism. I know that because I have a face right here and a face right here that are both congruent and parallel, number one. Number two, it's a polyhedron. Okay, it's a polyhedron because all of my faces are polygons, okay? So, when I say to find the surface area, here's what I'm saying. I'm saying to find the area of each face and then add them up. So, I have a front face, a back face, a left, a right, a top, and a bottom. Do I not? Look, here's the front. There's the front of my prism right there. See it? Now that's a rectangle. And if this is 7 here, then this is 7 right here. So I have a rectangle right here. It's a 4 by 7 rectangle. So the area of the front of my prism is 28. Now guys, if the front's 28, it does not take an aeronautical engineer to see that the back is also going to be 28. If this is 4, then this is 4 right here. So 4 times 7 would be 28. That's decently obvious, okay? Now the left side is also a rectangle. Here's the left side. It's a rectangle, okay? And it is, if this is 6 right here, then this side right here is 6. And if this height is 7, then that means this right here would also be 7. So we have a rectangle that's 7 by 6. Well, 7 times 6 would give me an area of 42 for the left side. Well, students, the left side right here is the exact same rectangle as the right side over here. So the area of the right side would also be 42. Now the top of the prism, well, if this is 4 right here, then this side right here is 4. And if this is 6 right here, then this right here would be 6. So I have a rectangle, it's a 4 by 6. So the area of the top of the prism is going to be 24, 4 times 6, and the bottom will be the same as the top, so also 24. Now add all of those up, and we get what? Sorry about that. We get 16, 20, 24, 28, carry my 2, 2, 4, 6, 8, 10, 14, I think 188. Now I did do that quickly, but I think that's right. Let's check it again to make sure. 8, 10, 12, 20, 28, 2, 4, 8, 12, 18. I think that's right. And we're going to call that square units because it is area. It's surface area. So guys, I asked you not to take notes on that. I hope you listened to me, okay? But I just want to show you what surface area is. It's finding the area of each face and then adding them all up, okay? Now, Mr. Earhart, is that how we're going to actually solve these problems? You can if you want to, and some of you might prefer that, okay? However, I would like to suggest, well, let me come back to this comment here in a second. I would like to suggest to you that you use a formula, okay? What I just showed you is a great way to find the surface area of a prism. It's a great way, okay? But boy, I'll tell you what, I'm not a big fan of formulas, but if you can use a formula, it's going to help you, because unfortunately, guys, there are other prisms that aren't this nice and pretty and easy, okay? And the surface area is much more difficult to find, so a formula is going to be very helpful. Now, so I'm going to give you this formula that gives you the surface area of any prism. Using this formula might be a big help to some of you. Some of you might prefer this method right here, and that's fine, but you have to make that choice. Okay, now, back to this comment. Let me quickly show you what lateral surface area is, okay? Lateral surface area is so simple. It's just the surface area. Are you ready? Take notes on this, please. Lateral surface area. What is lateral surface area? It is the surface area minus the two bases. That's it. It's that simple. So if I ask you to find the surface area, then you find the surface area of the entire prism. But if I say find the lateral surface area, then you can find all the surface area and subtract out the top and the bottom. So back here, if I said find the lateral surface area, then you would subtract out the top and the bottom, which is 24 and 24, 48 together. So you would take 188 minus 48, and that would give you 140 square units. Okay, and that would be the lateral surface area, if you want to make note of that in your notes. So surface area is the surface area of the entire polyhedra prism. The lateral surface area is the surface area minus the bottom area and the top area. Okay, hope that makes sense. Alright, so here's that formula I was talking about, okay? So simple, there it is. Please copy that down. Capital S equals 2 times capital B plus capital P times H. Now, after you've copied that down, you're going to want to know what some of these letters stand for. So here they are. I would make note of this. Capital S stands for surface area. So this formula helps us find the surface area. By the way, in your notes, make a note of this. This formula is for prisms. I would make note of that in your note, and I should have already done that. Now, capital B stands for the area of the base. Capital P stands for the perimeter of the base. Isn't that easy? And H stands for height. This is going to be a lot faster than using this method back here where you found the area of each side and then add them up. Now, that's a good way to do it. It eliminates memorizing a formula, but I'll tell you, you might want to use this formula when we get into some harder problems, okay? So let's try this formula on the last problem that we just did. So there it is, alright? So here we go. Let's use our formula. Surface area equals 2 times capital B, area of the base. Well, area of the base is 24. That was easy enough. 4 by 6, the area of the base is 24. Plus, now the perimeter of the base, well, the perimeter is 4 plus 6 plus 4 plus 6. Is that not the perimeter all the way around the base? 4 plus 6 plus 4 plus 6. Well, that's going to be 20. So I have 20. That's the perimeter of the base times the height. The height is 7. Well, let's see. 2 times 24 is 48. 20 times 7 is 140. Add these together, we get 188. By the way, what if I asked you to find the lateral? Let's stop right there. So that's the surface area, okay? And that's the exact same answer we got way back here when we did the problem right here. We got 188 square units, okay? That's a lot faster. The formula is now. What if I asked you to find the lateral surface area? Then cross off the two bases. Just cross it off, and all you want is this right here, and that's the lateral surface area right there, 140. So if you want to make note of that in your notes, feel free to, okay? So this formula here allows you to find the surface area of the entire prism. If I ask you for the lateral surface area, then cross this off, and just use this right here. Make note of that in your notes, please, okay? Alright, thank you. Let's continue on. If I'm going too fast, just pause the video. Now, let's do one more problem using this formula, okay? By the way, if you don't want to draw this, if you're not a good artist, if you're just like me, not a good artist, then in your notes, write page 594, example 2b. Please copy that in your notes so you'll know where the problem came from, okay? And here we go. Alright, let's find the surface area of this problem. Now, first of all, is it a prism? Well, we have this face right here, which is parallel and congruent to this face here. So yes, we have a prism, okay? So with that in mind, here's how you find the surface area of a prism. Now please don't forget, this is 4. This formula only works on the surface area of prisms. Got it? Okay. So the surface area is 2 times capital B. Capital B is the area of the base. So here's the base right here. Looks like a right triangle to me. Okay. So we're going to find the area of a right triangle. Well, the right triangle looks like this. Here's the right triangle. This edge right here is 4, right? See that? Which makes this edge down here 4. So this would be a 4. This edge right here is 3, correct? So this would be 3. So what's the area of this triangle? Well, 1/2 times the base times the height gives me the area of the base. So it would be 6. 4 times 3 is 12 times 1/2 is 6. So the area of the base is 6. Got it? Now, let's find, next is the perimeter of the base. Let's find the perimeter of the base. Well, here's the base right here. Here's the base right here. To find the perimeter, I must know all 3 sides. Okay? So using Pythagorean's theorem, I do have a right triangle. I can find this 3rd side. Trust me, I'm not going to take time and do that. It will be 5, trust me. So what's the perimeter of this base? Well, here's your base right here. It's a triangle. What's the perimeter of that base? 4 plus 3 plus 5, 12. What's the height? Well, here it is, 2. That's pretty easy. 12 plus 24 gives me 36 square units. 36 square units. So that formula really does save you. Actually, square centimeters. Sorry about that. So centimeter square, because we are dealing with centimeters. This formula is really helpful, okay? Alright, now let's wrap things up. Let's look at finding the surface area of a cylinder. Again, I'm not a huge fan of formulas, but these formulas really make the math easier, so I'm going to recommend that you use these. Here's the formula you need to use when you are asked to find the surface area of a cylinder. I'm so worried you're all going to get these confused. If I ask you to find the surface area of a prism, it is 2 capital B plus capital P little h. Capital B area of the base, capital P perimeter of the base, little h height of the prism. If I ask you to find the surface area of a cylinder, here's the formula you would use. So please copy that in your notes. 2 pi r squared plus 2 pi rh. We're going to do this quickly and we're finished. Here we go. Please please draw this in your nose. I don't think this is too difficult. If I can do it, you can definitely do it. So if you're struggling with that, just draw kind of a flat circle, draw kind of a flat circle, draw a line straight down, draw a line straight down, and you've got a very nice cylinder that looks like it's been ran over by a semi-truck, right? So there is the cylinder. Now we're going to find the surface area of this cylinder. So what do I need? Well, I need a 2. Then I need pi, so 3.14. Look at this, guys. I'm just going right through the formula. R, well, the radius is 3. So 3 squared plus, what comes next? 2. What comes next? Pi. What comes next? Radius. And what comes next? Height, which is 5. So let me reach down here and grab my handy dandy TI graphing calculator, and let's see what we have here. 2 times 3.14 right here, guys. 2 times 3.14 times 9, because 3 squared is 9. It's going to give me 56.52. Now remember, in the book, they're probably going to use pi in the calculator. We're going to use 3.14, so our answers will be off a little bit. Over here, I'm going to type in 2 times 3.14 times 3 times 5. Okay? 2 times 3.14 times 3 times 5, and I'm getting, hopefully I'm doing this correctly, I'm getting 94.2. Okay, so if we add those two together, we're going to get this for an answer. The surface area of the cylinder is this right here. Okay, now can I show you something, please, students? This is the surface area. Got it? Everybody listening to me. What if I said to find the lateral? Please make note of this in your notes. What if I said to find the lateral surface area, then cross off this right here? That's what you don't want. So this is all you need for the lateral surface area. So the lateral surface area would just be 94.2. Please make note of this in your notes. I'm trying to help you and make this as easy as possible. So if I ask you to find the surface area, then you use the entire formula. This whole thing. If I ask you to find the lateral surface area, then cross this off. This is all you need, and that will be the formula to give you the lateral surface area. Okay? Alright, guys, hope this video has been a help to you. If you have any questions, never hesitate to call or email. Okay, and with that dramatic finish, my mouse is not working. So this is like a blooper reel at the movies. There we go. Alright, there we go.